Hello, I wanted to talk about this model of a flow downstream of a marine propeller that I made using FDM printing. We studied these flows in the laboratory at the university, and also they're a nice representation of transition from laminar to turbulent flow regimes that I often use in my fluid mechanics courses. The flow downstream of a propeller is generally turbulent, which is characterized by random fluctuations of all flow parameters such as components of velocity, pressure, etc. But on the background of that random turbulence, there are coherent structures. These are vortices that persist on a time scale longer than the shortest, kind of fastest fluctuations of the velocity components. So these vortices are represented here. So we regularly compute these flows using CFD, or we measure them in laboratory. But this model is a simplified parametric representation of these coherent structures. It's an analog of a schematic that I would use on the board, for example, when teaching a course. So this shows the main coherent structures downstream of the propeller. So these structures are these tip vortices that are shed from the tips of propeller blades, and also a hub vortex that originates at the hub, and it's in the core of this wake region. The flow is very regular and organized initially, very like in the near wake of the propeller. But eventually these vortices, they start to oscillate as they move and are convected downstream. The amplitude starts to oscillate and the vortices come together occasionally, they pair and leapfrog, and eventually completely break down into chaos, which I could not represent here. The tip vortices engage the hub vortex in the motion, and this is where transition to a complete turbulence happens. So the challenge is not only to capture fluid mechanics aspects of this flow and represent it in a parametric model, but also just manufacturability. So these vortices are relatively thin filaments that have long unsupported lengths, so it's a challenge for FDM printing. So I had to design these projections of the vortices as permanent supports. It's actually very illustrative. As the model was printing, I could observe the directionality of the vortices change. So I hope that this is useful both in terms of understanding the physics of the propeller wake and in terms of teaching the concepts of turbulence transition. So this is the first glance at representing the moving fluid as a stationary solid object and kind of the challenges that are involved in both fluid and solid aspects of creating kind of sculptural objects like this, which have physical significance related to fluid mechanics.